All right. So, new lesson. We're going to deal with the law of sines and cosines. Before I get going too crazy on it, when we did sine and cosine from the last section, what type of triangle did they always have to be? It always had to be a right triangle. So the stuff we did, where we had sine equals the opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. All of those had to deal specifically with right triangles. Okay, the stuff we'll get to today are going to be solving for triangles where we do not have a right angle. Okay? In order to get these ones, we will either know two of the sides and an angle, or we will have two angles and a side. But these are the ones that we're going to work through. It's in Google Classroom, or not Classroom. It's in Infinite Campus if you want to see what the assignment is. Okay, but anyway, that's the stuff we're doing. The stuff before had to deal with specifically with right triangles. So every single one of these was dealing specifically with right triangles. The stuff we're going to do today, and again, we've got a block day, so we should be able to get through it, is going to deal with ones that are not perfectly right triangles. Okay? If you do want to look and write these things down, it's on page 588. But here's the first rule for the law of sines. Again, we don't know the angles that are in there. I'll zoom in as best I can. So the law of sines says that lengths A, B, and C are all going to represent sides of a triangle. And then the opposite angles, so the angles that are completely on the other side of the triangle, are to be represented by like the capital A, the capital B, the capital C. Again, the same way I drew the triangle before, just this time we don't have a right triangle or a hypotenuse to deal with. So angle A corresponds to this side A, angle B corresponds to side B, angle C corresponds to side C. So the rule with the law of sines is that if we take the sine of A, so we actually, in your calculator, you punch in sine and then whatever the degree is, because remember, whenever you have sine or cosine, the number that goes immediately after that in your calculator is the actual degree. So if you punch in sine of A and you divide it by the length of A, it will be the exact same ratio as the sine of B divided by the length of B. Exact same ratio as the angle C, or sine of C, as the length of C. No matter what, using sine, the ratios will be the exact same. And then on this quiz test, I'll let you use multiple note cards. Anybody want a note card to write this one down so that way you can balance between the stuff and the assignment? Yep. 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 I gave you two. Here's one. Yeah. Just take one, pass back. Back. There you go. Again, my intent is because, again, if you're trying to solve this stuff, I realize that no one's going to try to memorize this stuff all the time. So use your resources. I'm good with that. But I want to make sure you guys understand. So besides just the formulas, Make notes on that sheet if you need to, so that way you understand what this stuff actually means. Okay, I'm gonna pull up my highlighter. That's the reason I kind of have this one here. Whoops. So again, this angle here, this angle A, is going to correspond to this entire side. This angle here, angle B, is going to correspond to this entire side. This angle C will correspond to this entire side. So that way when I'm looking at my ratios, sine of A will be over this entire length of side A. Sine of B will be over the entire length of side B. And then sine of C will be over the entire length of side C. The ratios will always be the exact same. Okay. All right, the other rule I'm going to give you, I'm going to add an extra little note on here, mainly because it'll make the rest of this easier. If they give you two angles, so two separate angles, if they give you this one, or this one, this one, this one, this one, this one, if they give you two angles, use the law of sine. You don't have to use inverse sine to go through it. So if they give you two angles, use this one. Okay? So I'm going to write it up here. Yes, you can solve it if you have two sides you're trying to solve for that one, but you have to use the inverse function. And a lot of times that's where people start making simple little mistakes when you're punching things in on your calculator. So if they give you two angles, you can kind of punch that stuff in right away, and you'll get decimals on the top, and you no longer have to worry about the sine or the sine functions punching them into the calculator. All right, so example 1. I'm going to look at it here. And again, I'll zoom in a little bit. If we needed to know this angle, could we get it? Just subtract it from 180, right? Because again, they give us 2, we can figure out all the other ones. So the stuff I'm going to make sure that we have, I've got this angle, and I've got a length that's opposite of it. I've got this angle, and I've got a side opposite of it. Perfect. They give me 2 angles. So now I can try to set it up to solve it. So the very first one I'll do, I'm going to have sine of 78. So again, I'm doing this one and the side that's opposite of it. So sine of 78 over 8 is going to equal the sine of 60 over x. Taking the angle and then the side that's opposite of it. Angle, the side that's opposite. To make things a little bit easier, we're just going to punch this stuff in so we can work with decimals. So I've got sine of 78, which is, let me turn up my light just a smidge. Sine of 78, which on my calculator I got 0.978. You guys got that one? Anybody's calculators switched since last time we did some work? Making sure it didn't go over to radians. So I have 0.978 divided by 8 equals the sine of 60. That one's going to be 0.866 over x. Now it just turns into a regular cross multiplication problem that we did a ton of work previously on. Okay, I'm not going to spend a whole bunch of time doing the cross multiplication stuff, but you guys kind of got that one down. So if I did 0.978 divided by 8, that one gives me 0.122. If I wanted to write the full numbers out here, you can. Equals 0.866 over x. Cross multiply, I'd be left with 0.866 divided by that 0.12225. So the length of that side, so the x, when you got done doing that cross multiplication, should be left with 7.1. Because again, no matter what, both those ratios, for this one over this and this one over this, would equal that 0.12225. My ratios will be the exact same. If you would prefer to do it cross multiplication style, by all means, take these two times each other, these two times each other, and then solve for x. Okay? I'll do another one with your help leading me along the way. Here's my new triangle. I'll let you guys write it down, and then we'll talk some stuff before we start working it. All right, with my triangle, I've got angle S, 54, doesn't have a number opposite of it. Yes, so that one's good. Angle 37, does that have a number opposite of it? No. I'm trying to find this one. So if I want to find this, I have to figure out what the angle is for R. How can I figure that out? How many degrees are in a triangle? 180. Okay, so I've got 180 degrees in a triangle. I could subtract the other two sides of it. I could take 180 minus 37 minus the 54, and I'm left with this side equaling 89 degrees. Again, we just need two angles to make that one work. Because they gave us the two sides that we're trying to solve for, we didn't have this one, so we just had to subtract from 180 to get that missing side. Now, do we have the information we need to use the law of sines? Yes. Anyone feel brave enough to tell me one of the ratios? Like how I would write it using the sines, the law of sines. I'll write slowly. So I'll say sine of 54. What number should be underneath the sine of 54? 8. Fantastic. I've got this one here. 8 was opposite of it. So that's why I wrote that number. Perfect. So that ratio is going to be sine of 54 over 8. The next one, we know we needed to find that x, right? Which angle should I use for the opposite of x? What number? 89. Perfect. I've got sine of 54 over 8 equals sine of 89 over x. Now it turns into a cross multiplication. Cross products. I'm going to go through and I'm just going to do it actually cross product this time instead of giving you the decimal. That way, if you want to see it that way, we can do it that way. So I've got sine of 58, or sine of 54 times x. That's going to give me, that's going to give me 0.809 x equals, now I've got sine of 89 times 8. And that one's going to give me 7.999. To get x all by itself, I'm going to divide that number, or both of them, by 809, by 0.809, divided by 0.809. The length for side x is going to be 9.9. I'll just go to one decimal place. Did you guys follow the steps as I went? Anybody get lost along the way? All right, well, I'm going to have you guys do this next example. I'll zoom in as best I can. We're just going to talk it. So I've got 17 here. I've got the matching side, that's going to be the P. Do I know which angle I'm going to use for 12? Yes, no? No, I don't. So you'll have to figure out this angle first, and then I'll have you guys work through and use the law of sines. I want you guys to work this one on your own. Yes.
Okay, that's the button. Okay, just making sure.
Just for right now, 45, just make sure it's the right numbers.
This one?
Yep.
45.
No, okay, something off.
Awesome.
No, you did, it's yours is on radius. That's not unfortunate. Sign up for the- Yep. Yeah, like on the top, you ever see like this on the bar, it's hard to see.
Okay.
Nope, because they'll both be the exact same ratios. So yeah, sign up 17, 35, way over that one. Okay.
I was hoping like 5.
That equals. Nope, because you have to use whatever.
Wait a minute, do you get 20?
So I'll figure out what you use. Yes.
And then 20?
So you get 7 rounds, you get 6 cycles or 7. Perfect. Yep. Okay, so 17, what is opposite of 17 would be a P. Equals, so we have this length right here. So that'll be the top. And do we know what the cycle is?
Oh, why
You have to do that. So how can you figure out the second?
Oh, because I looked up.
You got it. Yep, you read right. Negative. What's it? That's fine. You can work around it depending on where you put your job is at. Yep. Yes, sir. You're paying. You can fill it right out. That's it. Yes. Nice job. So yeah, so. You always do the same, right? Yeah, we'll do sign up this cycle, so sign up 17. No, so that one you won't minus it all. So just go right to sign up 17. That's gonna be over. So if you just, you don't know what it is yet. So you just, they gave us this equals 12. Which one is opposite of that one? Q, do we know what that is? How do we solve it?
Yeah.
So 17 right in.
So you add both those up and subtract both those to figure out what the missing one is.
It's kind of hard.
Yes, sir. We're starting with the yes. So write it down. So start off sine of whatever angle equals or over another number. So which, let's start with 17. Okay, so write sine of 17. Over.
Oh,
Yeah.
What's opposite of 17? Yep. Okay, equals. Okay, then you can have the number, right? We need this number 12. Do we know the angle that's not in that?
7.
No, so I can figure out that angle.
And you can.
Yep, subtract 180 and go over
Oh,
You did. They should be at 17 instead of a 12, but yes. Yeah.
What?
Thank you. You could run up to this and see it.
Yep, so that's these. So you already figured out. That's the only. Just write that.
Got it.
Yeah. So the next ratio will be sine of that angle. I draw it. That is what that is. What? And what's the length of that? Yes, sir. Yeah.
I do already
It should be a
have
first session of 134.
Yeah.
That's fine.
The key is to drop.
I thought we were doing that last week.
Right?
I thought we did that last week.
Okay, so then the other ratio would be sine of 134 over what's the length that's opposite that degrees.
12?
Yes.
Yeah, that's my like.
So this ratio is.
We can't even do it with like 20.
Yeah.
Same process. All right, I'm going to go through the kind of steps that you should have had. Some of you guys are still doing the last little parts to solve it, but I'm going to go through those steps. Okay, we had this angle here with the side across, so we know that one was good. So I would have written that one as sine of 17 over p equals. All right, I've got this length, but I do not have that angle over there. So I'm going to add 17 plus 29, and I'm going to subtract that from 180. This angle up here should have been 134 degrees. So it should have been written as sine of 134 over 12. And now we get a cross multiply. Now we get to do sine of 17 times 12 equals sine of 134 times p. Okay, so if you did that one, and again, depending on where you round it to, so sine of 17 times, let me put it on there, sine of 17, times 12. That one should have been 3.508 equals sine of 34. Sine of 134 times p. You should have had 0.719 p. And then you would have got p all by itself. You should have ended up with p equaling around 4.88, depending on where you rounded at. Some of you guys had 4.87. Some of you guys had 4.86. I think somebody had just a 4.9. Again, depending on where you rounded at, your answer should have been close to 4.88. Okay? Questions on the signs, law of signs. Okay, what time are we done with this class? 11? Okay, before you guys get confused on stuff, I'm going to give you the first part of the assignment. Okay, I'll let you work on that. I'll give you around 10 minutes, and then I'm going to go over the last part, which will be the law of cosines. So the first part of the assignment will be, come on. This first part here, just the 12 through 20 even. 593, 12 through 20 even. Just do the first part And then in 10 minutes, we will go over the law of cosines.